Okay, class, if you're ready, we will look at the last derivative problem. And this is, again, a graphing problem. We got y equals 3/4 of x squared minus 1 to the 2/3 power. Let's first off find the y-intercept. Plug in 0 for x. We get y equals to 3/4 of 0 minus 1, negative 1. So we got negative 1 to the 2/3 power. Negative 1 squared is 1. Cube root of 1 is 1. So we got 3/4 times 1, which is 3/4. So I know on the graph I'm going to have the point 0, 3/4. Second thing I want to do is to talk about where this would be undefined. If you have the x squared minus 1 and you want to consider where it's undefined, you need to think about a radical. Well, this radical happens to be a cube root, so we can have positives or negatives under it, so this function will actually be defined everywhere. Okay, let's go on from there. Let's see if we can find the x-intercepts. Let's see what happens when we plug this and set it equal to 0. We would have 0 equals to, okay, 3/4 is not important here. And we would have x squared minus 1. I'm not even going to bother with the 2/3 power because whatever to the 2/3 equals to 0, that by itself would equal to 0. So, x squared equals to 1. So x equals to plus or minus the square root of 1, which is just plus or minus 1. So I've got 3 points so far. I've got the point 0, 3/4. I've got the point negative 1, 0. And I have the point 1, 0. So let's go from there. No vertical or horizontal asymptotes to worry about here. No slant or oblique asymptotes. So we'll go straight to the derivative. Y prime equals, we're going to get to do the chain rule here. 2/3 times 3/4 it'll be to the negative 1/3 and then times 2x. Alright? 2 times 2 is 4, cancels with that 4. 3 cancels with 3. So we're left with y prime as being x. This is to a negative exponent, so pull it to the denominator. It's going to be x over x squared minus 1 to the 1/3 power. Now, let's look for our intervals of increasing and decreasing. We're going to get the numerator, x equals to 0, okay? That's one place where the derivative is 0, and the derivative will be undefined. Also at plus or minus 1. So we've already got those points figured out, but those points will be where we will possibly change from increasing to decreasing. Putting it on a number line. I'll go with negative 1, 0, and 1. Picking the different values, let's go with negative 2, negative 1/2, 1/2, and 2. Alright, plugging in negative 2, I would get a negative over, this will be positive, so negative over a positive is negative, so I know I'm decreasing here. Negative 1/2, again that'll be a negative over, that will be a negative this time under the radical, so that negative to the 1/3 power will be negative, because the cube root of a negative is a negative, so negative over a negative is positive, so we're going to end up increasing here. Plugging in 1/2, It's a positive over a negative this time, so it's going to be negative, so it's going to be decreasing on the interval from 0 to 1. And then finally from 2 to infinity, I'm going to guess it's probably going to be increasing. 2 over positive over a positive is positive, so we're increasing. So we switch from decreasing to increasing to decreasing to increasing. So that's going to mean we will have a minimum, a maximum, a minimum. Now let's check for concavity. Again, we'll use the second derivative there. Second derivative, low being x squared minus 1 to the 1/3 power minus d high, of course, is 1, low d high, minus high. High is going to be x. Y'all are probably saying high. Oh, anyway, I'm sorry, that was off topic. And then we have x squared minus 1 to the negative 2/3 power, and then times 2x. And this will all be over x squared minus 1 to the 2/3 power. You should have told me that I was writing off the page just then. Anyway, there we are. We got some messy arithmetic to straighten up, so let's go ahead and get with that. 2x times negative x will be negative 2x squared, and that's going to be negative 2x squared over x squared minus 1 to the 2/3 power. Alright, now for the other part, it's x squared minus 1 to the 1/3 power. But when I multiply that by x squared minus 1 to the 2/3 over x squared minus 1 to the 2/3, getting the common denominator, I end up with x squared minus 1 and again, all of that will be over x squared minus 1 to the 2/3 power. X squared plus 2x squared will give me, or is that, no, never mind, I'm sorry, that's positive right there. X squared plus 2x squared will be 3x squared. No, x squared minus 2x squared will be negative x squared. I knew I'd get it eventually. So I'm going to have negative x squared minus 1 over, and this denominator will combine with this denominator, and it'll be x squared minus 1 to the 2/3 squared, or x squared minus 1 to the 4/3 power. Now, let's see what the critical values will be here. As far as saying the numerator equal to 0, it will not equal to 0. The denominator is still going to be undefined at negative 1 and 1. So, let's see what we get here. Plugging in negative 1, we're going to get a negative, so it's going to be concave down. Plug in 0, we get a negative, concave down. Again, the numerator is always going to be positive here. And then we plug in a negative for a bigger number, and we still get concave down. So it's going to be concave down everywhere. Now, part of the time it's going to be concave down and increasing. Part of the time it's going to be concave down and decreasing. And when we graph this out, we see this will be our result. We're going to decrease to negative 1, then we'll increase. This is the point 0, 3/4. This is also the point positive 1. So we're decreasing in concave down, we're increasing in concave down, we're decreasing in concave down, and we're increasing in concave up. And what we see right here is we've got some corners. Right here, this is not differentiable. But that's okay, because remember, when we did the first derivative, we said that it would not be differentiable there. So that is the graph of 3/4 of x squared minus 1 to the 2/3 power.
Again, for homework, you have a problem that's to the 2/3 power. So hopefully this problem helped you out.